Is Shailesh Prasad, or maybe if you see my tag, Shailesh, maybe something which Australia has done to me, repeating my first name as my surname. But then, yeah, here. So I'm a part of Schneider Electric, catering as a product manager for protection portfolio, out of which one piece of the basket is arc flash, and yes, it's very critical. That's why we are here. There are two parallel sessions running on arc flash, and you can understand the demand for it, one in 3.5, one in 3.4. So starting on the unleashing safety piece, which is, so if I have to explain the title will elaborate and touch on the basic fundamentals of arc flash for sure, but we'll also talk about the right mitigation technique, because that's very critical. Everyone is aware of arc flash, everyone is aware of the intensity of arc flash. But now we have to understand, how do we mitigate it? How do we quench it? How do we mitigate it? In terms of mitigation also, what's best? Okay, so that's something where I will be putting more focus on, and then in the end we can take some questions. So moving on, this is the topic, unleashing safety, mastering arc flash mitigation techniques. The agenda will flow like, we'll understand phenomena of arc, which is more and less known to everyone sitting here, because few of us are interacting on my booth. Then we talk about principles of arcing, because if we understand principle pretty well, in depth, in detail, that only drives the right proposition or selection of choosing the right mitigation technique, okay? And hence point number 3, which is comparing the passive mitigation versus active mitigation. Fourth point, which is we go one level down on the active mitigation. We have two types of offerings. One is integrated, one is dedicated. I'll give you some pluses and minuses, and I'll give you my recommendation as an OEM recommendation who manufactures these devices, that which one should be used widely. Then we go ahead with the penultimate session of schemes and applications. And then we'll end with some digital experience, what Schneider as a company, as a brand, can offer to you on arc flash, and what are the use cases. So this is the short summary or gist of the agenda, or the flow of the agenda. I'll quickly start with the arc flash phenomena. So arc flash phenomena can be a short circuit, can be any small accident, can be any small error, human-based, a tool which is left inside the substation, inside a switchboard, a rodent, reptile, entering something. What it leads to? It leads to excessive amount of energy. Energy in the form of heat, pressure, temperature, gas, sound, and we call this as arc flash or flashovers. Average, and again open party source. We are talking about an arc flash incident can cost you between 250 kilogram to $15 million. You can calculate the average. In nutshell, it's pretty expensive. So as you can see, I have to blur one image, and this is a disclaimer. Anyone who's not okay with viewing a sensitive image or a content, because this is one of the outcome of an arc flash at one of the substation, pretty famous on YouTube platform. I have used in my slide just to show you the severity of the arc flash, what arc flash can lead to. In terms of temperature, it can go up to a range of 20,000 degrees Celsius. Okay, and now I'm kind of removing the sensitive content, and you can see what has happened to an animal which has entered a substation, led to an flashover, and something of this sort can be a reality. So temperature can lead to this. Sound can really lead to a lot of damage to a human being. And there is an extreme level of pressure, or you can say a severe shock. So I have to go back and follow the protocol and make it more still sensitive. So this is just to show you a glimpse of what an arc fault damage can lead to. If I go next, there are some myths. These are very common, popular myths. I have heard voice of customers, voice of users, voice of operators. Let's understand this one by one, and let's burst it. First one, arc flash assessments are only for large facilities. Not true. Critical applications, even small facilities needs arc flash. Study says, and voice and data sample says, lot of arc flash are happening more and more in low voltage system than in medium voltage or high voltage systems. So all facilities, including which has a footprint of low voltage and medium voltage, needs arc flash, needs the study, needs assessment, needs mitigation, deployment. Second one, PPE is enough. PPE might be enough for COVID, but not for arc flash. I am not recommending, and I'm saying on control of being an OEM and a product manager of this portfolio, that yes, we recommend PPE, but that's an additional layer of safety. That's not only PPE is not sufficient enough to take care of arc flash damages. Number three, that arc flash assessments are one-time events. See, if I have to calculate and total the number of experience of people who are sitting in this room, it'll be multiple 100 years. And we all know that whether it is a manned substation or an unmanned substation, how substations are dealt with or operated with, not only from an operator or a human being perspective, but also from conditions perspective, which is beyond anyone's control. And hence, assessments needs to be done on periodic manner. Many people says that, okay, I've done the assessment and now I'm free for like next 2 years, 3 years, 4 years, 5 years. It is a condition apply. It is not a exoem, it is not a permanent statement which you can make. Last but not the least, arc flash assessments are premium, very expensive, time consuming. See, I'll not debate on time because you know the advantages of it. I'll comment on expense. As a product manager from Schneider Electric, and I can tell you all my good competitors, all the players in the market, the way arc flash commercially has progressed in last 10 to 15 years, if someone has given me this statement before 15 years, I would have agreed that arc flash is a premium offer. But now the volume of arc flash globally has grown, and with scalability, the cost comes down. And the cost of arc flash has really come down, and now we can even have an arc flash as low as $1,000 or $1,500 system. So it's no more expensive, no more premium, okay? From these myths, let's understand the principle of arc. Why, where, when? Why? Aging of isolators, vibrations at connectors. The red ones or the highlighted ones are more probable or have occurred more, which is human-driven maintenance errors. Equipment broke. In terms of where, we, as a rule of thumb, arcing or sensors are prescribed to be positioned or located in 3 sections: busbar, cables, and circuit breaker. These are certain zones, or I would say hot zones, where the probability of having an arc or arc has already occurred. The sample of data we have is much more in these 3 zones. When? At any time due to aging, but not necessarily only because of aging. Many greenfield projects we are deploying arc due to abnormal work, and at the same time, or I would say the majority of the time, during maintenance and commissioning. So these are certain pointers why an arc flash can occur, where an arc flash can occur, and when an arc flash can occur. From here, let's understand the principle of arc flash with this term, which is very important to decide the mitigation technique, which is incident energy. Let's understand the synonyms of incident energy. Incident energy, if it looks too technical, let us call it as a dissipated energy, an energy which is coming out as an aftermath because a flashover has happened. So it will be a thermal energy. It influence the parameters like distance, current, duration. You see the graph. The graph shows the percentage of incident energy with respect to a working distance. And if I have to give you a literal definition or a definition which can be easily understood, it is an electrical worker's skin, the temperature on which is observed on the electrical worker's skin is known as a dissipated energy from a flashover. From this, let's try to understand on the protection and the mitigation piece, PPE. So PPE, there are 4 categories which are visible on the screen. Depending on the incident energy, I think we were discussing about what is the unit of measurement, at what level, what PPE, what hazard category we need to deploy. So this is the chart. All these informations will be passed on to you. And here we are defining as per the respective incident energy, what is your risk category, what are the consequences, and what is the PPE level you need to use. For consultants, for people who are engineers, who are driving specifications, this is something which has been asked multiple times by many consultants. So we are saying level 1, PP, go for it. These are the levels of PP, but don't stop here because you'll not be able to take the heat or really the hit of arc flash just by deploying PPE kit. So this slide, I'll spend a bit of time here. I've kept the content less. I'll do the commentary more. And intentionally, I have kept the slide like on the left-hand side, passive, on the right-hand side, active. Because we are doing a comparison. And in fact, right now, in the other room, we are talking about a lot of passive techniques. In this room, we'll talk a lot about active techniques. Let's understand dictionary meaning of passive-active. Passive, which is a bit, reactive in the sense, which happens a bit late. Active, something which happens instantaneously. Here also, the phenomena is same. When we are saying passive mitigation, that means a flashover is allowed to take place. And then you are doing a mitigation. When we are talking about active, then we are not allowing the flashover to reach to its zenith or the peak. Or incident energy is not allowed to be developed to a level that it becomes dangerous for the life of the operator or for the equipment. That's the difference between passive and active. Passive is something which is a part of the switchboard in the form of an arc compartment, or arc is contained. So in passive, people normally say there is a containment which is happening. There is no mitigation which is happening. A real mitigation happens in an active arc flash protection. Okay? So passive is also prescribed by standards, IC, ANSI. It protects both LV and MV cubicles. It contains the arc fault. And you have to really understand when you are containing the arc fault and when you are mitigating the arc fault. Okay? The definition lies, the understanding lies in terms of incident energy. So we will go to the next slide, and I will show you a simulation which is done on a dummy with the respective stages of the intensity of an flashover or an arc. So if you see this video, an experiment was conducted where arc flash was there for a few seconds, few milliseconds, I would say so, and it shows the damage which can be done to the equipment or to the operator. Now, the intensity is done severely, and you can see the damage has multifolded. And in the end, now we are talking about 500 milliseconds of exposure to a flashover. And in that case, you lose the life of the operator. At the same time, multi-million-dollar worth of equipments are no more there. So it's a huge capital loss. It's a huge life loss. What does this experiment concluded to? And I think I have the same graph on my booth where we says the x-axis is the duration of arc and the blue curve is the incident energy. More arc is exposed to the system, exponential damage it does to the system. Okay? And with this, what we have concluded in the calculation is, if you have to make sure that both the equipment and the personal life is secured, you have to ensure that everything is done within 100 milliseconds, including the operation time of the circuit breaker, which is typically 60 to 80 milliseconds. That means I have to operate the magic of arc flash mitigation within that 10 to 15 or 20 second bracket, for which Schneider has an answer. And the answer is a good answer, healthy answer, which is a big spread of offer. Why I'm stressing on a healthy or a big spread of offer, this is something which is in comparison to what is available in the market. If you see on the left-hand side, the first one, which is known as integrated offer. Integrated offer means you have a protection device which gives you all kind of protections: current, voltage, frequency, all the protections, all the ANSI codes are served. At the same time, you want something arc flash also in the same device. Then we have an offering by the name P5 or P3. The same product is available on booth in Power and Grid booth in one of the corner, and you can go and see it. That's where integration arc flash is offered from Schneider Electric. One device can cater up to 6 sensors. But from an OEM, from Schneider Electric, from our recommendation is always and always go for dedicated arc flash protection. It's a technical choice, it's a commercial choice, but I would say the concluded choice should be dedicated. In dedicated, we have a good panorama of offer. We have a standalone device, we have a basic system, and we have an advanced system. When we are talking about standalone device, per vertical, one device, 3 sensors or 4 sensors, job is done. Basic system, if you have up to 7 verticals, you can use this combination of A3 devices, master and slave, multiple sensors. It can go up to 50 sensors. Again, job is done. And last but not the least, which is the heaviest, we have an advanced solution of arc flash, which is WAM 321. In few months, it will be rebranded as A5 series. Then we'll have a A1, A3, or a A5 series, increasing complexity, increasing performance, increasing price as well. So WAM 321 or a future A5 can cater up to 150 sensors. So any big LV configuration, multiple incomer, multiple bus coupler configuration, things can be settled from an advanced system. So there are also optical sensors which you can see down below. There are categorically, there are two types of sensors. One is a point arc sensor, which is the first one with a white pen-like kind of a shape. This is a point arc sensor which has a viewing angle of 270 degrees. It is something which is attached to a compartment or a wall inside a bus bar, inside a cable, inside a circuit breaker compartment, and it can see 270 degrees in front of it if there is a flashover which is happening. Now, because it is attached to a compartment and the visibility has a limitation of 270 degrees, what do we do if there is a dark spot, or if there is a patch, if there is some corner, or if you have a big LV panel and we want to secure each and every dark spot from any flashover? Then you see these bundles of fiber optic cables. These are specialized cables which are developed, patented, and they run in big lengths from 5 meter to 10 meter. Every 5 meter, it can stretches up to 70 meter length. And with 70 meters, you can imagine how big a board can be. This will cover each and every corner of your switchboard. So this has a viewing capability of 360 degrees. So it has no limitation of 270. It can view, you have to just run this cable throughout your cable or a bus bar compartment. My recommendation or the use cases we have seen is a combination of point arc sensor and a fiber loop sensor. People have gone for a combination of it. Majorly incomers, they go for a kind of a fiber loop sensors. They run the incomer and the bus bar chambers through fiber loop, and for the respective outgoing feeders, they go for a point arc sensor. So you can approach us if you want to have some typical schemes, typical examples, use cases. We can also share those with you. There is something which we claim, obviously on the base of data, and there is something which standard asks for. So if I talk about standards, let me go to the next slide. These are certain standards which speaks about arc flash. Okay, few standards which prescribes, few standards which mandates. Now it's completely up to us how we imbibe it, how we accept it. But the standard tells that the arc flash operation time needs to be less than 10 milliseconds. Now, as a manufacturer, and knowing the criticality of arc flash, and knowing that when I'm asking all of you to go for a dedicated arc flash system, I am ready to offer 2 millisecond of arc flash operations time. So though the standard says go for less than 8 millisecond or 10 millisecond, Schneider offers less than 2 milliseconds of arc flash operations time. So this slide shows you a combination of point sensor or fiber loop sensor, as I was explaining. Certain sections, upstream, bus bar, breaker, cable, where you have to really position or locate your sensors. And these are certain standards. So again, these standards are pretty, so these standards shows you an evolution. It started from American world, where NFPA was in the picture and they were propagating ARC and all. Slowly Europe adapted it, and when America and Europe adapts, I think rest of the countries are pretty covered, because either we are following Americans or we are following Europeans. But IEC 62271-200 or a portion of 6150 GOOS does talk about arc flash. So we see push coming from standards. We see where these sensors needs to be located, and we also understand that with active mitigation and a combination of point arc sensors and fiber loop sensors, that's the beauty of arc flash complete solution. In terms of dedicated, I've shown you 3 offers: A1, A3, again something which is visible on my booth, and there is a WAM321. I've used 3 slides. One slide as a flashcard to show you what A1 can do. So with respect to A1, we are talking about, it's a cubicle protection, light detection. It's a standalone one. So we all know in electrical industry, we have installations from 30 years, 40 years, 50 years, depending on budget, depending on operators, depending on a lot of things. We never changed or completely replaced those switch gears with a new one. But we have to make sure that how a 30-year-old switchgear is also ARC compliant. This offer is the solution for this. PowerLogic A1, A125 can be connected to any third-party device. Need not to be a Schneider relay or a Schneider circuit breaker. So this can talk to ABB, this can talk to Siemens, this can talk to GE. So any third-party player, it will be able to communicate. Second, PowerLogic A3, something which we have introduced into the kitty almost 2 years back. It is adapted to multiple configurations. So you can understand that A1, which is a very basic device with 4 sensors, and WAM321 or a future A5, which is 160 sensors, sometimes become an overkill for a lot of your configurations. So in Australia or across world, a lot of people were deploying WAM321, which is a big elephant, for a 7 to 8 vertical kind of a switchboard. So in that case, our R&D came up with a solution, which is PowerLogic A3, again a master-slave phenomena. And using this, a combination of this, you are able to cover to multiple configurations. PowerLogic A5, which is the WAM321 master-slave configuration. In nutshell, one master can talk to 16 slave, and every slave can have 10 sensors. So again, after lunch, multiplication is not difficult. 16 multiplied by 10, 160 sensors. Ideally, one master can cater to. So this is the uniqueness, or I would say the heaviness or the intensity of the CPU of the master device, which is PowerLogic A5. Now, as I've shown you all the offers, what comes complementary with our offers? So something which is more of digital, something which can increase efficiency in terms of QRs. So first of all, you have to understand the offer, then you have to deploy the offer, then your operators have to be trained on the offer. So a lot of dependency on Schneider. So wrong, unjustified. So for which we are enabling you with all the literature, all the assets, straight from the device. You can scan. I think it's available now in majority of our products. And the dependency on arc flash is reduced. So we are trying to make you self-sufficient in order to use those devices. There are multiple how-to videos which are available on YouTube, which can explain you how to really do a basic setting, how to do a dip switch setting, how to operate, what to do in terms of troubleshooting. A lot of commissioning support will be there available. And last slide from my side, which is use cases across domains. So this is only Schneider Electric factual data. Till now, 3,000 plus studies and assessments were performed by Schneider Electric team. 100 plus licensed professionals are being trained for designing and compliant architectures. And when I say architecture, just one explanation is, you can come to us with an inquiry that I have my switchboard, can I have arc flash designing on this or recommendation from your side? We come back to you with specific positioning of sensors, optimized number of sensors. We don't want to really flood it with a lot of sensors. So those arc flash schemes can be given as an output from our side. And last but not the least, $30 million of revenue generations and 35% is the average cost saving compared to a full replacement of arc flash. That's it from my side. Thank you so much.